COVID-19. 8 million results. Is that just me, or it seems a little bit confusing? 8 million results in the past few months have come out of coronavirus. And that can be really, really, really confusing. So in this video, me and a few of my friends from GKS are going to be breaking down what coronavirus is. So the first question I want to ask is, what is COVID?
So not to be confused with coronavirus, COVID, more specifically COVID-19, is a disease. It's a respiratory illness which is caused by the novel coronavirus. Now, COVID-19 actually has a meaning. The CO stands for corona, the VI stands for virus, and the D stands for disease. So it is the coronavirus disease, first documented in 2019, hence the 19.
The second question I want to ask is, what is coronavirus?
So this particular coronavirus is a virus that we see right now. It is new to us, but we've seen the same type. So we've seen SARS, we've seen MERS, and those are the same type of viruses, except this novel coronavirus is something that we haven't seen before, which is why, therefore, it's novel, it's new. So a quick rundown of the activities. The coronavirus, it likes to attack type 2 pneumocytes, which are cells in the alveolus. They come in and they infect those types of cells. They use the ribosomes of our cells, which are parts and organelles of our cells, and they use that to convert RNA, their positive sense RNA, which they inject into our cell, and they use that to construct polyproteins. It's like a long chain, and it uses a protease to actually break the chain, and that way it can form parts of the virus. So the capsid, which is basically the ball of the virus if you look at it visually, and also the other types like the spikes. It also uses an RNA-dependent RNA polymerase to convert RNA into even more RNA. So once you have even more RNA, which is basically kind of the DNA of the cell or of the DNA of the virus, you have that plus the parts of the cell, you can construct brand new viruses. So it makes a bunch of new viruses. Now, once those are formed, exit the cell, they infect more ones. And so it's our immune response ends up creating our blood vessels to be more permeable, which means they have the ability to leak more plasma, which ends up compressing on the alveoli, causing difficult gas exchange. So that's really kind of what the coronavirus does in terms of what we see right now.
Well, now that we know what it is, where did it come from?
So what's very important to note is that we only have a couple months of information regarding the novel coronavirus, and that we do not have all the answers. But as of right now, the outbreak of this current virus is thought to have started in a seafood market in Wuhan, China, where sale of wild animals could have been the source of zoonotic infection, which pretty much means an infectious disease transmitting from non-humans to humans. As of right now, bats are thought to be the likely reservoir hosts for COVID-19, which pretty much means where the virus naturally lives and reproduces. And other than that, we aren't exactly sure of what hosts transmitted it to humans. What has recently been discovered is that pangolins, sometimes referred to as scaly anteaters, were found carrying related coronaviruses, and that has led us to believe that pangolins could have been possible hosts to the virus and transmitting it to humans.
All right, now we know what it is and where it came from. How does coronavirus, or COVID-19 specifically, compare to other previous pandemics in history?
Well, COVID-19 so far has caused more than 460,000 illnesses and more than 20,500 deaths worldwide. For comparison, in the U.S. alone, the flu has caused around 38 million illnesses and 23,000 deaths this season. That's according to CDC, the Centers for Disease Control and Prevention. So what's so special about COVID-19? Well, scientists have been studying the seasonal flu for decades, and we know a lot about flu viruses, so we know what to expect each season. On top of that, there is a vaccine for prevention of the flu. whereas COVID-19 is very new and we know almost nothing about, so it's a wild card in terms of how far it will spread and how many deaths it will cause. Some good stats to look at in comparing viruses are also death rate and virus transmission. So for the flu, New York Times says that the seasonal flu death rate is typically around 0.1%, but using CDC's numbers, it's less than 0.01%. Whereas COVID-19 seems to have a higher death rate, and despite us not having too many numbers and not having tested everyone who actually has it, in Italy right now it's estimated to be around 10%. In Spain it's pretty high, around 7-8%. But then in other countries it's very low, like 0.4, 0.5%. But regardless, it's higher than the flu. And in terms of transmission, how viruses are compared for transmission is their R0 value. So this is an estimated value of how many people each person who has it spreads it to. So for the seasonal flu, it has an R0 value of around 1.3, whereas COVID-19's is estimated to be between 2 and 3 right now. So that being said, the combination of us not knowing too much about the novel coronavirus, its significantly higher death rate and higher R0 value, and the fact that there is no vaccine yet is pretty scary. However, there is hope of a vaccine soon to come, as officials have launched phase 1 clinical trials for a potential vaccine.
So these coronavirus, the one that we see right now, is unique because, first of all, the spikes. So the spikes itself, the red parts of the virus that we see on the image, they're actually different. So they are ones that we haven't quite seen before. We've seen spikes before, but this particular structure, some scientists are thinking that maybe it's different from the SARS virus. So that's really what makes it different. And so this virus, its functionality, which is unique from others, really makes it different. And so right now we're just finding cures based on what we know of it. For example, when we talked before about how it functions, where the protease breaks the polyprotein chain, we're trying to inhibit that function, but that could potentially cause more harm. So the thing is, with this virus, it's hard to tackle because viruses in general aren't living things. Keep that in mind. They are not living things. They are things basically that come and infect our cells and use our cells' machinery. So if we do want to kill this virus, we have to kill our cells. And that's a big problem because it can interfere with our functionality. So if we're comparing bacteria, for example, some of the antibiotics, they tackle the cell membrane of the bacteria because that way it can break and destroy the bacteria. But with viruses, we have to kill our own cells first. So keep that in mind.
Thank you guys for coming on here. I hope everyone enjoyed listening about some of the facts that we've pulled together from the internet. We've done our best to get as much information as possible, and I'm glad that you stuck around to the end of the video. Hopefully you guys learned something about the coronavirus and COVID-19, and stay healthy.